All right, welcome to Chapter 3 and this is Section 2 on compound and continuous compound interest. So when at the end of a payment period, the interest due is reinvested at the same rate, the interest as well as the original principal will earn interest until the next payment period. This interest paid on interest reinvested is called compound interest. Now, the frequency that interest is computed and added to the balance is called the compounding frequency. The rate per compounding period is found by dividing the annual nominal rate by the number of compounding periods per year. And compounding quarterly means interest is computed and added each 3 months. Semi-annually means interest is computed and added each 6 months. And there's daily and other ones as well. So daily would be depending on if it's 365 or 360, depending on bank or not. And so you have that different thing. And so that's going to be how it works. And monthly would be every 12 times. So suppose $1,000 is invested into an account paying 6% annual interest compounded annually. How much is in the account at the end of 1 year? Okay, well, what we have to do is we have to think about what we have. And so let's do the principal. Oops. The principal is going to be what? 1,000. The rate is going to be 0.06, and it's compounded and time is equal to 1 because it's 1 year, it's compounded annually. And so what we're going to have first is we're going to have, what is A? Well, that's going to be the principal plus whatever interest we earned. Well, what is the interest earned? Well, interest, remember, is just PRT for simple interest. And so since this is just going to be simple interest compounded once at the end of the year, we're going to have 1,000 times 0.06 times 1. Well, multiply those two together, we get 60 times 1, so the interest is $60. So the future value is going to be the original amount invested, $1,000, plus our interest we got, which was $60. So that's going to be $1,060, and that's going to be our future value at the end of 1 year. Now, suppose it's invested into a account paying 6% annual interest compounded monthly. So here we had annually, here monthly. So monthly means every month is going to be adding that extra amount to it. And so how much is in account after that 1 year? Well, because there's a lot of calculations for this one, if we're going to do it the same way, I kind of am typing it out. So we're going to have some things here. So we're going to do the same formula, A equals P, and then times 1 plus R, because what really did that is just P, and then plus the interest here. That's P, and then P times R times the time, which is 1 in this case, is going to be that. So we just have principal plus interest. And that's going to be the amount at the end of each month. So P is the beginning balance at the beginning of the month, and R is the rate of interest. And end of month is basically, I'm going to rewrite as EOM. So at the end of the month, for the first one, we're going to have our 1 plus 0.06, our rate, divided by 12, okay? Because it's going to be 1/12. Because we're thinking about it, we have 1 month out of possible 12 months. And so that's going to be our time period. So we have to think about that. We have to remember to make that 1/12. And so when we multiply all this together and add it and everything, we end up with 1,005 because this piece here is just equal to 1.005. Now, what if we do it for the second month? Well, we're going to do the same thing. We're going to have basically our 1,000 times the 1.015 times, what's this? Well, that is 1.015. So that's really 1,000 times 1.005 to second, which ends up being this. And so now this is going to be invested. And we're just going to keep doing this. And so if you notice, it's going to go up by 2. So it goes to 3, then 3 goes to 4, 4 goes to 5, 5 goes to 6. And like I said, this is why I didn't handwrite all this out, because it's a lot of writing. But what happens is at the end of the 12 months, we have this formula, okay? And so we have 1,000 times 1.005 to the 12th, and that's going to be our ending value. So in the previous example, it was invested for 1 year, and with annual compounding, we found it was only 1,060. But when we did this one, we found 1,061.68 when we compounded it monthly. Okay, so now the difference in these results comes from the difference in the method of compounding. So that's a key thing. The more often you can compound it, the more you're going to get as far as interest goes. So you compounding it once per year, you only get 1,060. Compounding it 12 times per year, you're going to get 1,061.68. What if we compounded it daily? It would get something a little bit more. It's not going to be much more, but it's going to be a little bit more. And so then eventually we're going to get to compounding continuously. And so that's going to be something that you really, if you could ever get that on a bank account, that would be what you want. And you'll never get that though. Okay. So the monthly compounding example took 12 different computations, but we can actually simplify this process a lot using a general formula for the compound interest where only one computation is required. And that computation is as follows. The future value is equal to the principal times 1 plus the rate. Number of compounding periods is m, and m times t is the exponent. So in our case, when we did it 12 times, the 12 every month, we had 1,000 plus 0.06 divided by 12, and then 12 times 1 because t was just 1. Now, if t had been maybe 25, this is going to start getting to be a bigger number, and so then you're going to have a bigger number here when you get done. But with just that 1, it really doesn't do a lot of effect. It just raises it to the 12th power. So, but this is going to be our equation that we're going to use for compounding interest. It's going to make it a lot easier than having to go through all of these to get to that final value, especially if you have to do 25 years. All right, so let's stop there and we'll come back with more.